Hello everybody. So today I want to talk about calculus. The topic today is about we want to find the volume of donut of lifeboat. So now I want to show you how to answer. We know that the cross section of the donut and the lifeboat that is about the circle. Now let's say I will put this one into OSY. So we need to put the center of the circle on Y axis. So we know that this one we will use about R, and from this one to this one I will put about 8. So the center of the circle in here, that should be about 0, A plus R, and the radius of the circle that is about R. So this point in here to this point in here, we will have about positive R in here and negative R in here. So if we have the information in here, we can apply the standard formula of the circle. So we have C, A, B, and the radius that is about R. So we will have about S minus A to the power of 2 plus Y minus B to the power of number 2 equals to R square. So A that is about number 0, B that is about A plus R, and now we apply this one and we have S square plus Y minus A minus R, everything to the power of 2 equals to R square. The next one, if we want to find the volume, we need to know that we need to find the upper function and the lower function. So the upper function that is about this one. The lower function that should be about this one in here. So we have this equation. Now I will put this one go to the, I will put S square go to the right. Later that we put the square root for the both sides. So we have the positive square root and the negative square root in here. So negative A, negative R, I will put on the right. Now we can apply the formula of the volume. That should be about B, and we have the integration from negative R to positive R. Because we want to rotate this circle around about S axis. So the upper function that is about this one, because this number plus to this number, So this one they will go up in here. This one minus, so this one should be about the lower. Minus the lower in here. Now we need to expand this one. And we have like this. So if we simplify everything in here, we just have like this. Now we need to concentrate about this interaction in here. So this one we can use about integration by trigonometric substitution. So I will put about s equals to r sine theta. So if we do first derivative for the both sides, and we have the s equal to r cosine theta d theta. Because if I put this one go in here, we will have about r square sine theta square, r square, we can do about factorization. 1 minus sine theta square, we change by cosine theta square, and later that we simplify the square root. Next, we need to change the bounds. So, when s equal to negative r in here, so negative r divided by r, so we have sine theta equal to negative number 1. So that means when s equals to negative number 1, negative r, theta equal to negative b over 2. When s equals to r, so theta equal to b over 2. So about s we change by r sine theta. This one we have cosine theta d theta. So r square, we can do about factorization. So this one we change by cosine theta square in here, and we put outside the square root, and we have r cosine theta, and we have another cosine theta. This one we have cosine theta square. If we multiply through cosine theta, and we have the formula in here. So I will put this one cone here. Because I just put number 2 outside, that's why we have 1/2. So the integration of cosine 2 theta, we have 1/2 sine 2 theta. Number 1, that is about theta. And we put the power from negative b/2 to positive b/2. So this one, I will put this one cone here, and negative b/2, I will put this one cone here. And then we just have only 1/2 or b/2 minus negative b/2, we have positive b/2. This one, we just have 1/2 or b. So the integration of this one, we have this one in here. We have 4a plus r and b, they are the constant. And now we can simplify like this. I need to edit, I'm missing about on here, so we put cone here. We have r square here. And this is the final answer we need to find. This is the end. Thank you for watching.